the beginning of everything. Imagine standing at the edge of existence, looking out into the vastness of space. For as long as humanity has gazed at the stars, we've wondered where it all began. The question has haunted us for millennia. How did it all start? From the birth of stars to the formation of galaxies, the origin of the universe has always been a subject of intrigue and awe. For most of history, humans believed the universe was eternal, existing forever in a steady, unchanging state. Ancient civilizations looked to the night sky and saw a pattern of stars, constant and timeless, a grand cosmic clockwork. It was only with the rise of modern science that this notion began to be questioned. Could the universe, in all its vastness, have a beginning? In the early 20th century, a breakthrough discovery shattered the long-held belief that the universe had no beginning. Astronomers observed that galaxies were not stationary, as previously thought. They were moving away from one another, suggesting that the universe itself was expanding. This revelation came from the work of Edwin Hubble, who, in the 1920s, discovered that the farther a galaxy was, the faster it appeared to be moving away from us. This expanding universe was a critical piece of the puzzle, but it led to an even more profound realization. If galaxies were moving apart, it meant that at one time they were all much closer together. In fact, this led to the theory that the universe began as an infinitely dense and hot point, a singularity, a beginning so extreme that it defied all understanding. The Big Bang Theory. This singularity, where time and space as we know them did not exist, marked the birth of the universe. This moment, known as the Big Bang, was not an explosion in space. It was the creation of space itself. It's a difficult concept to grasp because we are so used to thinking about explosions as happening in space, but the Big Bang was the beginning of everything: space, time, and all the matter that would later form stars, planets, and galaxies. In the first few moments after the Big Bang, the universe was incomprehensibly small, hotter than any furnace we could imagine, and filled with pure energy. As the universe began to expand, this energy cooled and turned into the building blocks of matter. In the first few seconds, subatomic particles like quarks and electrons formed. As the universe continued to cool, these particles combined to form atoms, the simplest elements, mostly hydrogen and helium. It wasn't just the formation of atoms that made this time so critical. The universe was expanding at an extraordinary rate. This rapid inflationary period, a moment of immense, almost instantaneous growth, allowed the universe to go from being smaller than an atom to a vast expanse in the blink of an eye. This cosmic inflation reshaped the entire fabric of reality, setting in motion the creation of everything we would later know. But the question remains: where did the Big Bang come from? What was before the Big Bang? For a long time, the answer seemed to be nothing. But as science advances, we realize that the answer may be much more complicated. Some scientists propose that before our universe, there were others, and that the Big Bang was just the latest in an endless cycle of expansion and contraction. Other theories suggest that the universe could have emerged from a quantum fluctuation in a vacuum state. Whatever the answer, the fact remains that the universe, as we know it, began in an instant, a sudden burst of energy that forever changed the course of existence. The expanding universe. As the universe expanded, gravity took over. Clouds of hydrogen and helium gathered into clumps, and these clumps formed the first stars and galaxies. The light from these early stars lit up the darkness, and for the first time, the universe became a place of visible structure. But the universe didn't just continue expanding, it continued to evolve. Over billions of years, galaxies collided, stars were born and died, and planets formed around those stars. Our own solar system, with Earth as its third planet from the Sun, was born about 4.5 billion years ago. The Milky Way, the galaxy that contains our solar system, has a much longer history, with stars that are billions of years older than the Sun. This galaxy, like countless others, is part of an ever-expanding cosmic web. a vast network of galaxies that are connected by gravity. Yet, as grand as the expansion of the universe is, something far more unexpected happened. The expansion didn't just continue in a straightforward way, it started accelerating. This discovery, made in the late 1990s, was one of the most surprising of the 20th century. Scientists observed distant supernovae, exploding stars, and found that the light from these stars was fainter than expected. This meant that the universe was not just expanding, but the expansion was speeding up. This phenomenon was caused by a mysterious force, which came to be known as dark energy. Dark energy, as the name suggests, is still a great unknown in the field of physics. It's believed to make up about 68% of the universe's total energy, yet we can't directly observe it. What we do know is that dark energy is the driving force behind the accelerated expansion of the universe, pushing galaxies apart faster and faster as time goes on. The discovery of dark energy raised more questions than answers. What is dark energy? Where does it come from? And what does it mean for the future of the universe? If dark energy continues to push galaxies farther apart, could the universe one day be torn apart entirely? Or will the expansion slow down and eventually reverse itself, leading to a cosmic collapse? A universe in motion. The universe as we know it is in constant motion. Galaxies rotate, stars orbit around the centers of their galaxies, and our solar system moves through space as part of the Milky Way galaxy. And yet, despite this motion, we feel as if we are standing still. The Earth rotates on its axis at over 1,000 miles per hour, and it orbits the Sun at around 67,000 miles per hour. Yet, from our perspective, everything feels static. In the same way, the universe moves on a scale so grand that we can't even begin to comprehend the full extent of it. The galaxies are rushing away from each other at an accelerating pace, yet the forces involved are so large that we are only beginning to understand their impact. As the universe expands, it carries us further from other galaxies, but there is something comforting in the fact that, for now, we are still part of this cosmic web. Our place in the universe, though tiny in comparison to the vastness of space, is still significant. We are here, alive and aware, sharing in the infinite journey that began billions of years ago. The secrets of dark energy and the expanding universe. As we continue to unravel the mysteries of the cosmos, one of the most baffling and captivating discoveries of modern cosmology has been the revelation of dark energy. This force, which makes up about 68% of the universe, is responsible for the accelerated expansion of space itself. But what is dark energy? How does it influence the universe? And more importantly, how did we come to realize that it exists? The discovery of dark energy came not from direct observation, but from studying distant supernovae. In the late 1990s, astronomers were studying the light from exploding stars, supernovae, in an effort to measure the expansion of the universe. They expected to find that the universe's expansion was slowing down due to the gravitational pull of matter. However, to their astonishment, the supernovae appeared dimmer than expected, suggesting that the universe's expansion was speeding up instead of slowing down. This unexpected acceleration pointed to the presence of an invisible force, dark energy, that was counteracting gravity and pushing the galaxies apart at an ever-increasing rate. Unlike gravity, which pulls matter together, dark energy appears to push it apart, creating a cosmic force that seems to defy the very laws of physics. This discovery changed everything. It suggested that the universe is not only expanding but accelerating at a rate that could eventually tear galaxies, stars, and even atoms apart. The true nature of dark energy remains elusive. We know that it makes up a vast portion of the universe's total energy content, but we have no idea what it is or how it works. Dark energy is not a substance in the traditional sense. It's not made of matter, nor does it interact with light. It doesn't exert a force in the way gravity or electromagnetism does. Instead, dark energy appears to be a property of space itself, a force embedded in the fabric of the universe. Some theories suggest that it might be linked to the vacuum of space, while others propose that it could be a new form of energy that we have yet to fully understand. As perplexing as it is, Dark energy is shaping the future of the universe. If it continues to push galaxies apart at an accelerating rate, the cosmos will continue to expand indefinitely. In the far future, galaxies will drift so far apart that they will be invisible to each other. Stars will burn out, leaving behind only black holes, white dwarfs, and neutron stars. Eventually, even these remnants will fade, leaving behind a universe that is cold, dark, and empty, a state known as the heat death of the universe. But the story of dark energy does not end with its discovery. It has opened up new questions about the ultimate fate of the cosmos. If dark energy is truly the driving force behind the universe's expansion, could it one day cause a catastrophic event known as the Big Rip? In this scenario, the expansion of the universe accelerates to the point where it overcomes all other forces, tearing apart galaxies, stars, and even atoms. The universe would end not with a bang, but with a violent, irreversible tear that destroys everything in existence. The future of our solar system. While the distant future of the universe is still shrouded in uncertainty, the fate of our own solar system is more predictable. In about 5 billion years, the Sun will enter its final phase of life. It has been burning for around 4.5 billion years, using hydrogen as fuel through the process of nuclear fusion. But eventually, the hydrogen in the Sun's core will run out, and it will begin to fuse helium into heavier elements. This will cause the Sun to swell into a red giant, increasing its size and luminosity. As the Sun expands, it will begin to engulf the inner planets, including Mercury and Venus. In its final moments, it may even reach Earth, boiling away the oceans and stripping away the atmosphere. This will mark the end of life on our planet, but it won't be the end of the Earth itself. As the Sun expands, it will shed its outer layers, creating a planetary nebula. What remains will be a white dwarf, an incredibly dense and hot remnant of a star that will slowly cool over billions of years. While Earth's fate is sealed, it will not be the end of everything. The outer planets, Mars, Jupiter, Saturn, Uranus, and Neptune, will likely survive the Sun's transformation into a red giant, but their own fates are still uncertain. They will remain cold, lifeless worlds, orbiting a dying star until the time comes when the Sun's remaining energy is finally exhausted. The ultimate fate of stars and galaxies. As we look beyond our solar system, the fate of the stars and galaxies that populate the universe is equally fascinating and terrifying. Most stars will eventually reach the end of their lives, but their paths will vary depending on their size. Smaller stars, like the Sun, will eventually swell into red giants and shed their outer layers, leaving behind a white dwarf. Larger stars, however, will die in a much more dramatic fashion. They will explode in a supernova, releasing an enormous amount of energy and scattering their elements throughout space. These elements, carbon, oxygen, nitrogen, iron, are the building blocks of life, and they will go on to form new stars, planets, and perhaps even new life forms. But what happens to galaxies when their stars die? Over the course of billions of years, galaxies collide, merge, and break apart. Our own Milky Way is on a collision course with the Andromeda Galaxy, and in about 4.5 billion years, the two galaxies will collide and merge. While stars in each galaxy are separated by vast distances, the collision of these galaxies will disrupt their gravitational fields, causing the stars to move into new orbits. This collision will eventually lead to the formation of a new, larger galaxy. However, galaxies don't remain static. As the universe continues to expand, galaxies will move farther and farther apart. The Milky Way, Andromeda, and their neighboring galaxies form the local group, but as dark energy accelerates the expansion of the universe, the galaxies will eventually be separated by such vast distances that they will no longer interact. The universe will grow increasingly isolated, and the once dense clusters of galaxies will be left in isolation, floating in the cold, dark void. The end of the universe. A cold, silent future. As the universe continues to expand and dark energy continues to push galaxies apart, It is likely that the universe will eventually reach a point where all stars have burned out, all black holes have evaporated, and all that remains is a cold, empty void. This is the ultimate fate of the universe: heat death. In this final state, there will be no more stars, no more galaxies, no more life. The universe will be in a state of perfect entropy where energy is evenly distributed and no work can be done. There will be no movement, no change, and no possibility for new creation. The universe will have run its course, and all that will remain is the silent, dark expanse of space. The unseen forces of the cosmos. As we look deeper into the vast cosmos, we begin to see that the universe is governed by forces far beyond our everyday understanding. While gravity and electromagnetism are the forces that we encounter most frequently on Earth, the larger universe is shaped by hidden forces that we are still only beginning to understand. Among these forces, dark matter and dark energy are the most mysterious. The enigma of dark matter. Dark matter, which makes up about 27% of the universe, is a force that has no direct interaction with light or ordinary matter, making it invisible to our eyes and telescopes. It doesn't emit, absorb, or reflect light, which is why we can't see it directly. However, we know it exists because of its gravitational influence on visible matter, such as galaxies and galaxy clusters. Without dark matter, galaxies wouldn't have enough mass to hold themselves together. In fact, dark matter is the glue that holds galaxies in place. When scientists observe galaxies, they notice that the stars at the edges of galaxies are moving much faster than they should be, based on the visible mass of the galaxy. According to Newton's laws of gravity, these stars should be flung off into space, but they remain in orbit, bound by an invisible force. This unseen force is dark matter. It is thought to be composed of particles that interact only through gravity and possibly the weak nuclear force, which is why it remains undetected by our current instruments. Dark matter is not just present in individual galaxies. It is a critical part of the cosmic web that stretches across the universe. The universe's largest structures, galaxy clusters and superclusters, are held together by dark matter, forming the backbone of the universe's architecture. Without dark matter, the universe would look drastically different. Galaxies would likely fly apart, and the formation of stars and planets would be much less stable. Scientists are still working to understand the true nature of dark matter, but some of the most promising theories suggest that dark matter could be made up of WIMPs, weakly interacting massive particles, a type of particle that interacts weakly with normal matter. If dark matter is made of WIMPs, we may one day be able to detect these elusive particles, shedding light on one of the universe's greatest mysteries: the accelerating expansion of the universe. While dark matter is a force that pulls things together, dark energy does the opposite. It pushes things apart. Dark energy, which makes up about 68% of the universe, is responsible for the accelerated expansion of the cosmos. When astronomers first discovered the expansion of the universe in the early 20th century, they thought it would gradually slow down due to the pull of gravity. However, in 1998, observations of distant supernovae revealed something surprising. The universe's expansion was speeding up, not slowing down. The force behind this acceleration was later named dark energy. Unlike dark matter, which interacts through gravity, dark energy is thought to be a property of space itself. It exerts a repulsive force, causing galaxies to move away from each other at an ever-increasing rate. This acceleration is so strong that it is causing galaxies to move away from us faster than the speed of light, pushing the farthest reaches of the universe beyond our observational capacity. Dark energy is a perplexing force, one that we don't fully understand. Some scientists speculate that it could be a form of vacuum energy, a kind of energy inherent in the fabric of space. Others propose that it could be a result of the nature of space-time itself, perhaps linked to the cosmological constant introduced by Albert Einstein in his theory of general relativity. No matter what dark energy truly is, its effect on the universe is undeniable. It is the reason why the universe is expanding at an accelerating rate, and it could ultimately lead to the universe's fate. If dark energy continues to accelerate the expansion of the universe, it could eventually lead to a scenario called the Big Rip. The Big Rip, a chaotic end. The Big Rip is one possible fate of the universe, one that is driven by the continued expansion caused by dark energy. In this scenario, the expansion of the universe accelerates to such a degree that galaxies, stars, and even atoms are torn apart. The force of dark energy would overpower the gravitational forces holding galaxies, and even the fundamental forces that bind matter together. As the universe's expansion speeds up, the distances between galaxies would grow larger, and the galaxies themselves would be torn apart. The stars within those galaxies would stretch and distort, pulled apart by the increasing force of dark energy. Eventually, even the atoms that make up matter, protons, neutrons, and electrons, would be ripped apart, leaving nothing but a sea of radiation and scattered particles. The timeline for such an event is still uncertain. If dark energy continues to increase in strength, the Big Rip could occur within the next 100 billion years or so. It would be the ultimate end of the universe, a chaotic disintegration of all matter and energy. However, there are alternative theories that suggest the universe could end in a different way. One such theory is the Big Freeze, where the expansion of the universe continues at an ever-decreasing rate, and galaxies, stars, and planets slowly fade into darkness. In this scenario, the universe would become an isolated, cold place, where stars burn out and black holes eventually evaporate, leaving behind only the faintest traces of energy. The future of our own solar system. While the ultimate fate of the universe is still uncertain, the future of our own solar system is a bit more predictable. In about 5 billion years, the Sun will enter the final phase of its life. As it runs out of hydrogen fuel in its core, it will begin to expand into a red giant, engulfing the inner planets, including Mercury and Venus. The Earth, too, will be affected, its oceans boiled away, and its atmosphere stripped by the Sun's intense heat. In the final stages of its life, the Sun will shed its outer layers, forming a planetary nebula and leaving behind a dense remnant known as a white dwarf. This white dwarf will gradually cool and fade over billions of years, leaving behind a dark and lifeless solar system. The fate of Earth and the other planets will be sealed, but before the Sun's transformation, the Earth will remain a lifeless, frozen world long after life has vanished. While the end of the solar system is assured, humanity may not be around to witness it. But even in the far distant future, the legacy of life on Earth could remain in some form. The atoms that made up our bodies, the carbon and oxygen, that were once part of living organisms will scatter across the cosmos, eventually becoming part of something new. Perhaps one day, new stars and planets will form from the remnants of what once was, and the cycle of the universe will continue, endlessly repeating. The infinite cycle of the cosmos. As the universe continues its expansion, we are left to contemplate the deeper implications of its inevitable fate. While the end may seem bleak, the universe's story is far from a singular event. It is an ongoing cycle that could, in some ways, never truly end. Even as the stars burn out and galaxies drift apart, new possibilities for creation and renewal could emerge. But what does this mean for the ultimate purpose of the cosmos? Is there an overarching design to everything we see, or is the universe simply a product of random chaos and chance? The end and rebirth of the universe. In the distant future, when galaxies have spread so far apart that they are invisible to one another and all stars have burned out, the universe will enter its final stage. This era, often referred to as the Dark Era, will be a time of absolute stillness. The remnants of stars, white dwarfs, neutron stars, and black holes will be all that remains of the once vibrant universe. The energy that once fueled the creation of stars and galaxies will have dissipated, and the universe will slowly cool down to a state of near absolute zero. The Big Rip, Big Freeze, or Big Crunch may all lead to a final, silent end. But there is a concept that gives us hope. The idea that the universe could be part of an eternal cycle. Some scientists propose the cyclic model of the universe, which suggests that the universe may go through endless cycles of birth, evolution, and death. After one universe reaches its end, whether by the Big Crunch, the Big Rip, or another means, it may give birth to a new universe, potentially as a result of a big bounce. This cycle could go on infinitely, with each new universe being the rebirth of the previous one. In this view, the ultimate fate of the universe is not a singular event, but a continuous process of transformation. Each iteration of the universe is different from the last, yet all are linked in a never-ending series of expansions, contractions, and renewals. The death of one universe could lead to the birth of another, with new stars, galaxies, and possibly even life forms. It would be a cosmic rebirth, where the cycle of creation and destruction continues endlessly. The multiverse. Infinite possibilities. But could there be even more beyond our universe, beyond the cycles we envision? The theory of the multiverse suggests that our universe may be just one of many. These universes, which could exist in parallel dimensions or with different physical laws, might each have their own unique fate. Some universes could undergo a big rip, while others might collapse into a singularity, giving birth to new universes in entirely different ways. In the multiverse theory, each universe exists independently of the others, but they all share one common trait. They are part of an infinite, ever-expanding reality. The implications of this theory are staggering. If there are infinite universes, then the possibilities for existence are endless. There could be universes where the laws of physics are completely different, where life has evolved in entirely unforeseen ways, or where even the concept of time is experienced differently. The multiverse concept challenges the very nature of reality, suggesting that our universe is just one small piece in a much larger cosmic puzzle. If the multiverse theory is correct, the death of our universe would not be an absolute end. The multiverse could continue to generate new universes, each with its own unique history and fate. Each new universe could have different rules, different constants, and different forms of life. The potential for creation would be limitless, and the cycle of existence would extend far beyond our understanding. The legacy of the universe. Even as the universe winds down and its final remnants fade into the void, there is a powerful legacy that lives on. The atoms that once made up stars, planets, and life will be scattered across the cosmos, woven into the fabric of future universes. The energy from dying stars will be absorbed into the cosmos, perhaps feeding into the birth of new stars and galaxies in the next cycle. The legacy of existence, in all its forms, matter, energy, life, will be carried forward, perhaps in ways that we can't yet comprehend. And what of life? As the universe fades, so too will the possibility of life in the conventional sense. Yet the materials that gave rise to life on Earth, the carbon, the oxygen, the nitrogen, will continue to exist, scattered throughout the cosmos. The very atoms that once made up living organisms will become part of the next chapter in the universe's ongoing story. In a sense, life's legacy could live on in the energy and materials that flow through the cosmic cycle. While life as we know it may end, the potential for new life in a new universe remains, and perhaps in the farthest reaches of time, life will once again emerge in a completely different form, sparked by the remnants of the universe that came before. The ever-expanding journey of the cosmos. Even as the universe approaches its final stages, it is important to remember that the universe is still an active, ever-evolving entity. Its fate may seem sealed, but its story is far from over. Whether through the endless cycles of cosmic expansion and contraction, or the birth of new universes in the multiverse, the journey of the cosmos continues. The motion of galaxies, the formation of stars, the evolution of life. All of these are part of a greater cosmic dance. This dance is one of creation, destruction, and rebirth, a cycle that has played out for billions of years and will continue for billions more. The universe, in all its vast complexity, is constantly changing, constantly growing, and constantly moving toward the next chapter. The story of the universe is not one of finality, but of endless possibility. The cosmos will continue to evolve, to expand, and to create, long after we are gone. It is a journey without end, a journey that stretches across the infinite expanse of time and space. And as we look up at the stars, we are reminded that the universe is not just something we observe, it is something we are a part of. We are, for a brief moment in the vast timeline of the cosmos, a part of this grand cosmic dance, a part of something that will never truly cease. The end.